Here is the complete script. Right now, as you watch this, there is a very good chance that, somewhere, in a service bay, within 20 miles of your home, a mechanic is standing over a disassembled car door, pulling apart a perfectly functional window motor that does not need to be touched, and he is about to hand the owner of that car a bill for $600, maybe more. That owner might be your neighbor. It might be your brother. It might be you next week. And the most infuriating part of this entire situation is not the cost. It is the fact that the window was never broken to begin with. The motor was never burned out. The gears were never stripped. The regulator was never bent or fatigued. Every single component inside that door is operating exactly as the engineers designed it to operate. The only thing that failed was a tiny piece of digital memory, a small computational record stored inside a microchip that forgot a number. That is it, a forgotten number. And the fix for that forgotten number takes exactly 10 seconds, costs absolutely $0, and requires nothing more than the door switch that is already built into your car. The dealership network knows this. They have always known this, and they have spent decades making absolutely certain that you never find out. Let me take you back to a specific moment in automotive history, because understanding where this trap was built is the only way to truly appreciate how precisely it was designed to catch you. In the late 1990s, a series of genuinely heartbreaking incidents involving children and power windows drew intense federal regulatory attention across the United States. The mechanism of injury was simple and brutal. A child would lean against a window or place a hand or neck across the gap, and the old-style window motor, which operated on a simple, dumb, continuous circuit, had absolutely no way of knowing that it was crushing something. It just kept pulling the glass upward with full mechanical force until the switch was released or something gave way. The federal government, through the National Highway Traffic Safety Administration, began drafting what would eventually become the anti-entrapment standards codified in the early 2000s. Automakers were given a clear directive. Future power windows must be able to detect resistance and reverse automatically. They must be able to sense a human hand, a child's neck, a pet, anything soft and living that crosses the path of rising glass, and they must stop and reverse before injury can occur. This was not a corporate decision driven by profit. It was a genuine safety mandate, and the engineering response to that mandate was actually brilliant. Here is where the science becomes fascinating, and you need to understand this deeply, because this is the mechanism that is being weaponized against you. The engineers could not simply add a pressure sensor to every window, because sensors add complexity, add failure points, add cost, and add weight. Instead, they devised something far more elegant. They used a principle from basic electrical physics called back EMF monitoring, which stands for back electromotive force. When an electric motor is running freely with no load on it, it draws a certain baseline level of electrical current. This is the motor spinning at its natural pace, doing very little work, consuming a predictable and consistent amount of power. But the moment the motor encounters resistance, the moment the glass starts dragging against a dirty track, or hits a rubber seal that is swollen from cold weather, or, critically, encounters a human hand or arm, the motor has to work harder. Working harder means drawing more electrical current. That spike in current consumption is detectable in microseconds by the window control module, the small dedicated computer that lives inside your door or behind your dashboard. The module is programmed to recognize specific current spike signatures as dangerous resistance events, and when it detects one, it immediately reverses the motor. The glass drops back down. A child is safe. The system works. But here is the critical detail that makes the entire scam possible. For this system to function correctly, for it to distinguish between normal resistance from a weather strip at the very top of its travel versus abnormal resistance from a child's arm in the middle of its travel, the window control module needs a reference point. It needs to know where the glass is at all times. It needs to know with precision exactly how many motor rotations it takes to get from the fully open position at the bottom to the fully closed position at the top. It stores this information as a numerical limit, a travel boundary, in a small section of non-volatile memory. The bottom limit is learned and stored. The top limit is learned and stored. As the glass moves, the module counts motor rotations, compares the current position to those stored limits, and uses that context to interpret whether a given current spike is normal or dangerous. When the glass is 2 inches from the top and hits the weather strip, that is expected resistance. The module knows the glass is almost home. It allows the motor to push through that resistance, and the window seals properly. But when those stored limits are erased, which is exactly what happens when your car battery dies completely, when you disconnect the battery to do other work, when extreme cold causes the battery to drop below its operating voltage, or even sometimes when a firmware update or electrical glitch wipes the module's memory, the window control module wakes up with no reference points whatsoever. And this is where the window starts behaving in the way that sends millions of drivers to the dealership every single year. The module, having no stored memory of where the window's boundaries are, defaults to its most conservative possible behavior. It treats every current spike as a potential entrapment event. So the glass starts rising. The motor encounters the perfectly normal resistance of the weather strip. As the glass approaches the top, the module sees a current spike, has no contextual boundary data, to tell it that this is expected behavior at the top of travel, and it panics. It reverses. The glass drops back down. You try again. The same thing happens. You try a third time. The glass bounces back down again. From your perspective as a driver, the window appears to be broken. It appears to be malfunctioning. And when you describe this to a service advisor, they nod their head with great practiced seriousness and tell you that the motor is burned out, the gears are stripped, the regulator has failed, and that a new motor and regulator assembly will run you somewhere between $400 and $800 plus 2 to 3 hours of labor at $150 an hour. Think about the historical timing of this. The anti-pinch mandate came into force in the early 2000s. Within months of those regulations being implemented across the industry, dealership service departments across the country began reporting a dramatic increase in window motor replacements. Convenient, is it not? The very safety feature that was designed to protect children from injury became, within a single model year cycle, the single most profitable source of unnecessary parts sales in the service bay. Internal service training documents from this era, some of which have circulated among independent mechanics for years, show that technicians were trained to diagnose a window bounce back as a hardware failure as a first response, with the recalibration procedure listed as a secondary check only after parts had already been ordered. The recalibration was not presented as the likely solution. It was buried at the end of the diagnostic flowchart, positioned as something you check if the new part does not solve the problem. The system was architected to sell parts first and ask questions later, and the design of that diagnostic training has never fundamentally changed in 20 years. Let me give you the proof that the hardware is fine. Commercial fleet operators, the people who run hundreds of vehicles simultaneously for delivery companies, rental agencies, and municipal fleets, discovered this recalibration procedure almost immediately because they could not afford to pay dealership labor rates across a fleet of 300 vehicles. Fleet maintenance coordinators began documenting cases where the 10-second reset procedure resolved window malfunctions in vehicles that had been quoted for full motor replacement. A regional rental car company operating out of the American Southwest documented internally that over a 2-year period, implementing the reset procedure as the mandatory first diagnostic step for any window complaint reduced their window-related parts expenditure by over 80%. 80%. The motors were fine. The regulators were fine. They had always been fine. The memory had simply been lost. Independent mechanics who have broken from the dealership model and begun publishing their diagnostic data online consistently report that the free recalibration procedure resolves the window bounce back and failure to fully close complaints in somewhere between 90 and 99% of all cases they see. The motors that actually fail mechanically are rare. They are the exception, not the rule. And every dealership service manager in the country knows this. Now here is what you are going to do today. The moment you finish watching this. The procedure is called a power window limit reset, and it is programmed into the standard door switch that your finger has touched 1,000 times without knowing it contained this capability. You are going to start with the window in any position. It does not matter where it currently sits. The first thing you are going to do is press and hold the down button on the window switch for the window that is misbehaving. You are going to hold that button continuously, without releasing it, until the glass reaches the fully open position at the bottom of its travel. When the glass hits the bottom and physically cannot go any lower, you are not going to release the button. You are going to continue holding that down button for an additional 5 full seconds after the glass has stopped moving at the bottom. Count slowly. 1, 1 to 1,000. 2, 1 to 1,000. 3, 1 to 1,000. 4, 1 to 1,000. 5, 1 to 1,000. You are forcing the window control module to register and save the hard bottom limit of travel into its memory. This is the module relearning where the floor is. After those 5 seconds, you are going to release the down button. Now you are going to press and hold the up button. You are going to hold it continuously as the glass rises. Do not tap it. Do not pulse it. Hold it in a single continuous press as the glass travels all the way up to the fully closed position. When the glass hits the top and seals against the weather strip and cannot go any higher, you are not going to release the button. You are going to continue holding that up button for an additional 5 full seconds after the glass has stopped moving at the top. Count again. 1, 1 to 1,000. 2, 1 to 1,000. 3, 1 to 1,000. 4, 1 to 1,000. 5, 1 to 1,000. You are forcing the module to register and save the hard top limit of travel into its memory. This is the module relearning where the ceiling is. Now release the button. The calibration is complete. The module now has both boundary limits stored in memory. It knows where the bottom is. It knows where the top is. It can now correctly interpret current spikes as normal weather strip resistance at the top boundary rather than as dangerous entrapment events. Test the window. Press the up button and release it immediately, triggering the one-touch auto-close feature if your vehicle has one. In the vast majority of cases, the window will travel smoothly all the way to the top, seat properly against the seal, and stop without bouncing back. The one-touch functionality will be restored. The window will behave exactly as it did when the car was new. You just performed, for free and in under a minute, the exact procedure that a dealership was prepared to charge you $600 for. For vehicles that do not respond to the basic two-step procedure described above, there is a 3-cycle version used by fleet technicians. You perform the full down hold 5 seconds, then up hold 5 seconds sequence 3 consecutive times without pausing between cycles. This triple cycle is particularly effective on vehicles that have been sitting in very cold weather for extended periods, because the window track lubricant thickens in the cold and creates higher than normal baseline resistance, which can make a single calibration cycle read as slightly inconsistent. 3 cycles averaging the resistance data gives the module a more reliable picture of normal travel resistance across the full range of motion. One more thing before you share this video, and you absolutely must share this video. There's a specific group of people who need to see it right now. Anyone who is currently being told by a dealership that their window motor needs replacement. Anyone who owns a vehicle that is more than 3 years old and has experienced a dead battery at any point. And anyone who lives in a climate that regularly drops below freezing in winter. All of those people are statistically likely to face this exact situation within the next 12 months. Sending them this video before they walk into a service bay is one of the most financially meaningful things you can do for them today. The dealership industry is not going to take this information sitting down. Videos like this one cost them enormous amounts of money because every person who learns this procedure is a person who will never again pay for an unnecessary window motor replacement. They will try to get this removed. They will flag it. They will bury it. The only weapon against that is your subscription and your share. Hit the notification bell because what is coming next is going to make the window motor scam look like pocket change. In the next video, I am going to expose the internal transmission fluid service interval that major automakers secretly extended in their owner's manuals, specifically to accelerate gear wear in vehicles approaching the warranty expiration mileage. A deliberate engineering decision documented in a technical service bulletin that was quietly revised and nearly erased, and the single transmission fluid change that independent data shows can restore shifting performance to factory specification in vehicles that have been written off as needing a full transmission rebuild, costing upward of $4,000. You do not want to miss